All right, looks like we're ready here. Hello, everyone. Welcome to another exciting episode of ARMS Innovation Coffee. I'm joined here by Alessandro. Let's go for a clink there on the coffee cups.
Here
Clink.
we go.
So as I mentioned, another exciting episode of Innovation Coffee. Today, we're joined by some folks from Arduino. In fact, not just anyone. We're joined by Massimo Banzi, who is the Arduino co-founder, and Sebastian Romero, who is the lead interaction designer at Arduino as well. We have some really cool stuff to cover. But as usual, we do like to do a little recap of last week's episode. So I'm going to pass the mic over to Alessandro. He's going to give us a little recap, and then we'll jump into this amazing interview with our guests.
Awesome. Thank you, Robert. Hi, everyone. So last week we had Raspberry Pi. So we had the team from Raspberry Pi talk about their new Pico board. And it was a really good show. I mean, you can find the link below. We'll post it in the video. And, we were thinking, how could we make this better? How could we top Raspberry Pi? So we invited Arduino. So I'm really excited for today to actually have a chance to talk directly to Massimo and ask him some interesting questions about the story around Arduino and the Portenta board specifically. So I think I've covered it. Robert, was there anything else?
I think that's good. I just want to remind everyone that we do answer questions. So while we're going through this entire hour of demos and talking heads, we do take questions. So post those questions in the chat. We'll take those. If you haven't already liked the video, just scroll down, like the video, follow ARM Software Developers for this weekly live stream. We're here every week. So keep us posted.
Awesome. So I think it's time, right? We could bring the guests in.
Absolutely.
So Massimo Banzi, co-founder of Arduino, and Sebastian Romero, lead interaction design at Arduino. Hello, welcome. Welcome to the show, guys.
Good evening.
Good evening. It's nice to see you. I see, Massimo, you've got a different background from what I'm used to. I see some old school computers there. Interesting.
My collection of old computers. That's my very first computer I've ever had in my life, the ZX81.
Oh, wow. You still have it.
I afford the Spectrum, so I bought the ZX81.
So you're not streaming from that today?
No. I'm sure that with the right software you could.
Yeah.
But I was designed in Cambridge, UK.
Oh, wow.
Right
where ARM started.
Yeah. I also have a BBC Micro somewhere, but it's in the other room.
Awesome.
I'm sure, Massimo, you could drop a little Arduino microcontroller in it, and then you could perfectly stream from that machine.
Totally. Well, you can from a Portenta.
There you go.
I plugged the product. I was super ready. You can see I worked
it
in the marketing department.
It is Portenta special, so you did the right thing. You should show the Portenta right away. That's what we're going to talk about. But before that, actually, I'm keen to have a chance to hear your backstory. So both of you, I think we've got similar stories in the sense that you guys both came from interaction design, and then came to electronics. So I'm really keen to kind of hear your story and how you got to Arduino and where you're now. So maybe we could start with Massimo and then Sebastian.
Yeah. Okay. I'll be quick. I learned. What is it? So I learned electronics from this book when I was 6. That's got.
Did he cut out, or is that me?
Your audio's gone, Massimo.
The
beauties of being live. Oh, it's back. It's back.
Stream to mute itself. I don't know. I didn't do anything. But anyway, I learned electronics from this book. That's got little electrons jumping around when I was 6 years old. And that was, this thing stayed with me for a long time. Then I got into computers. But I think the most relevant part is that probably about 19 years ago or something, I started to teach at this place called the Interaction Design Institute, Faire, where I was teaching designers how to use electronics to prototype and build real-life working objects out of the designs that we're kind of dreaming about. And then out of that experience, then Arduino happened, and then it became official in 2005. And then, after all these years, here we are.
Interesting. And I guess maybe we could, Massimo, we'll talk about some more stuff. What's coming. We're going to have some pictures for you. So we'll talk about more background story in a few minutes. But I think, maybe Sebastian, you could tell us a little bit about your background story and kind of fill in on what makes an interaction designer interested in electronics.
Absolutely. I think I'm a bit luckier because I was born later, so a lot of the things were already solved by Arduino by the time I got interested in it. I think for me, it started really early when I was a child, I think, and with the good old Microsoft DOS environment where you were able to put in some commands and then it would respond with something that was not predetermined. To have an interaction with an animate object was really fascinating to me. And I think I had that again when the iPhone first came out, because that really brought together the digital with the physical space. And to me, it was really this idea of being one of those people who could make new things for smartphones, to produce things that would show up on those screens was really tempting. So I studied computer science, and I didn't really know much about electronics then, to be honest. So having all these tools then in my backpack, after a while, I started to sort of question the value of the things that I was making back then. And, I had basically myself as the main target audience in mind, which clearly doesn't work. And then I wanted to learn, how do you actually make something that provides value to the people? And I think that really got me into interaction design. So I went to Denmark to study interaction design, and that's where I met Massimo. So he was actually my teacher there, and I learned about Arduino, and I was really fascinated again by this concept of embodied interactions, to modify objects, to make them smart, to add new features to it, to make them customized to your needs. And I think that was the only time when I started to learn electronics, because before that at school, I didn't really have, an application for it. But all of a sudden, a whole new world opened up to me. And I think all I learned about electronics, I learned it while I was with Arduino.
Yeah, my first, sorry, go ahead.
That's why I'm here today.
Yeah. I was going to say my first, I remember very clearly, my first microcontroller board was an Arduino Uno, and I bought it in this little kit that came with all the, wood cutouts and motors and sensors and LEDs, and then a book that you could follow, end to end from beginner to advanced. I had just such a blast. That was when I was in college. And, electrical engineering, we're learning all this paper engineering, but to actually put it into application and to actually, first year, second year, you're not really doing much with your hands yet. But that was just an amazing experience. So, I mean, I've been with Arduino, I feel like since day one, it feels like.
Nice.
Yeah.
Really nice. And I was going to say, Sebastian, I think you've done an Italian training to pronounce Arduino correctly, right? Because you sound Italian when you say it.
It's one of our official languages in Switzerland, so you gotta know a little bit about it, I guess.
Cool. Okay, so I think that's really interesting, because it's interesting to see that there is this kind of background of trying to make these devices usable and easy to develop on and so on. I really like that. I'm really passionate about that, and I think we'll talk more about that later. But before diving into more of Arduino stuff, I wanted to kind of do a bit of a segment. Robert, is it time yet?
It's time.
Yeah.
What's on your? No, it's. What were you thinking? Thinking what's on your desk. No, yeah. What were you thinking? This is a segment we did last week. We do this every now and then. We find some fun pictures of some of our guests, and we ask them what were they thinking. So, get a little bit more of an insight as to what was happening in those times. So, yeah, take it away. Let's do it.
Cool. So let's start. So, what were you thinking. So this is a picture I found. It sounds like, I mean, it looks like it's one of the oldest pictures I could find of you, Massimo. So I'm curious, what were you thinking here? What is this about?
This is when Wired magazine was doing a photo shoot for the first edition, the very first issue of Wired magazine in Italy had an article about Arduino, and they came to take pictures in the studio I had in Milan, which was before I moved to Switzerland. And so I, it was kind of half staged, so they kind of randomly put stuff. I think I was thinking, when can I go home? Because, these photo shoots, they're very long. Also, they put a lot of effort into this. So there was like a lady, opening books, putting things in the right places. And then they randomly took that blackboard, the chalkboard at the back, which basically has a shopping list on it. It says, bread, wine, onions. They found it on the other side of the studio and they put it there because they thought it sounded a little bit cooler. They also hang some wires randomly from the ceiling. It's kind of I'm basically saying, when can I go? When can I go?
Wait, so this scene was staged a bit. You're saying like all the wires were hanging kind of.
So some of the electrics were coming from the ceiling anyway, because this place was used to be a garage where they fixed cars. So it was a former garage. So all the electric was coming from, but they added some, there's some network cables randomly hanging from there. And then there's like a green lamp. Why do I need the green light bulb there? No? So it's just, it needed to be looking like the genie, the crazy scientist lair or something like that.
It's artistic.
Yeah.
Modern day Einstein.
What was happening in Arduino at the time? Like, what were you developing? What kind of boards did you have out? Do you remember anything about?
I think when this picture was taken, the current Arduino board was the Arduino 2009, 2009 it was called. And the Arduino Uno was not, we were prototyping the Arduino Uno during that time. So
awesome.
I don't even know what's that thing on the wall. They glued some Arduino boards on the wall with blue tack with some random sensor. And then that.
Oh, yeah, I see it down here, yeah.
I don't even know what that poster is. It was just found somewhere else and just put there. Yeah, so that was the time when I was, let's make it short. But during that time, really Arduino wasn't really able to support me with like a real salary. So I was mostly doing installations and interaction design projects. And so that was my studio with some other people. And I was working on Arduino as kind of my sort of unpaid job. So the stuff you see is mostly stuff I use to build projects with.
Awesome. I mean, that's an interesting background story. I never heard of that. So it's interesting that, you started off like that. That's super cool. So let's go to the next picture. This picture, where was this? What were you thinking here?
Boy, was I fat. I self-body shaming myself. No, this one was in Edinburgh in 2012 when I went to TED Global, because TED has like one in California and they have two main TED. One is in California and the other one used to be in Scotland. So I was there on stage. And it's interesting when I listen to that video every once in a while, because somebody kind of points it out to me, but my voice is, I'm nervous. I'm very nervous. And by that time I was already giving like a lot of talks. So I was, but TED is super stressing because you have like 2,000 people in front of you. And, the other guests are like famous people. And then the guy who, runs TED runs like a very, it's super well organized. So everything, so you feel a lot of pressure. And also in a way, in TED, when I gave my talk, I thought, Jesus, everybody else is talking about insanely important, life-changing things. And here I am, I'm showing people making chairs or tweet when you fart. So I was like, what am I doing here? No, I was like completely in this imposter dilemma, situation. So,
I think this is super interesting because I see you as one of the kind of more inspirational speakers in the tech industry. I mean, when it comes to real, kind of from the heart, people speaking about what they're doing, what they're developing, what they've created, right? Because you've created this, amazing company, and everybody's everybody's using Arduino at some point in their life, right? So I think it's interesting that you also went through that, right? And it's interesting to share that story.
Just I'll add something in 1 second. One thing that happened the day before, every talk is rehearsed in front of Chris Anderson, the owner of TED. And before me, there was this professor of geopolitics from a big US university, who was an advisor to Bill Clinton, that. And, Chris completely destroyed this presentation. He said, okay, stop. You got to do everything from scratch. This is bad. And the next one, I was on the stage next to that. Okay, he's going to tell me to go back home and just, disappear. And actually it went well. And I was really shocked because the first guy had like super perfect presentation made by a designer. So, the whole thing is stressing, even for somebody that gives a lot of talks. That's a story of that TED.
I still think like every time I go up and give a talk, whether it's, in front of a small audience for a tech session or something during a conference or something a little bigger, never anything in front of thousands of people like that. But I still get nervous every time I walk in front of people. I couldn't imagine thousands of people with a pre-rehearsed scenario. It sounds, yeah. I mean, but you pulled it off.
Yeah, I did. But it's not easy. Like the first big talk I gave was about 1,500 people in Amsterdam. And when I pressed the space bar on my laptop to go to the first slide, the laptop froze. And I was like, everybody was looking at me. The laptop wouldn't wake up. It's never funny. No. You have another one. Oh my God.
I've got the last one, the last one of the three. Where were you here and what were you thinking?
Yeah, that's the last Maker Faire Bay Area I've been to. And also because I guess that was the last Maker Faire Bay Area they had, because after that they didn't organize another one. Maker Faire is like a big event, for me. I remember the first time I went to the Maker Faire, it costed me a lot of money to go to California and go there, because Arduino wasn't making that much money and stuff. So, it was all, I had to kind of gather the money left and right to go and do a number of. So the Maker Faire had become like a big, tradition. And I don't know. It's I had the perception that it was becoming more and more difficult to organize Maker Fairs, and there's another picture that's somewhere, or a video somewhere, where all the people that organized the Maker Faire gathered on a stage, and they kind of had some kind of they kind of waved the goodbye in a way, and it was almost like they knew that after this one is going to be very hard to do another one.
I wanted to be in that picture. I think Alessandro's in that. You're in it. There's a bunch of people that I knew who was in that picture. Is that the same one, Alessandro?
I think Massimo is referring to the one that from the staff of Maker Faire. We've got a picture where we've got a picture together at this Maker Faire. I think that, so it's two different pictures, but yeah, I think it's the same Maker Faire. Very interesting. Massimo, I think one question I wanted to ask you on this, actually, I think, kind of leading off into the next piece, I was going to ask you really, the maker movement was kind of started more or less at the same time when Arduino started, right? And I'm curious about two things. So the first one is, it's one of, for the Italians listening, maybe they'll recognize the style of question, but as Arduino made the maker movement, or as the maker movement made Arduino, I think, I always think about this. Is it, it's a bit of a chicken and egg problem, right? Like I feel like Arduino is at the core of the whole maker movement, right? And it's evolved from being a startup to being actually a successful company today, right? So I'm really curious about your take on that question.
I think that in a way, Arduino made the maker movement what it is or what it was, because in a way, Dale Dougherty started Make because he's always been very good at looking at what was coming. Remember, this is one of the people, maybe the person who invented the expression Web 2.0. So it's, so ability to look into the future. But at the beginning of the whole kind of Make, trying to organize the maker movement, they were trying to use other type of hardware that was very expensive, very, in a way, complex to program. I remember they had this thing that was like one of the first projects they published was this open source MP3 player, but the compiler, the C compiler, was $3,000. And I was like, what the hell, $3,000 for a C compiler? Come on, it's just, that's not possible, no? So in a way, Arduino, intersected the maker movement at the beginning and provided it one of the tools that made it possible. Because if you look at the 3D printers that, for example, happened at some point, they had different bits and pieces of hardware that were derived from Arduino. No, remember that the controller in the first MakerBot cupcake was called Sanguino because it was a derivation of Arduino. And with all the weirdness for an Italian to hear Sanguino, because with a different accent, Sanguino, it means I'm bleeding. So, whenever people make this name with Ino at the end and they don't know what they're doing, it always sounds a little bit weird. But yeah, so, this has influenced quite a lot the direction that the movement taken, was one of the, catalyzers.
So I there's a question that popped up in the YouTube chat, and I think that this might be something that Sebastian and you, Massimo, can answer here. It's on the same lines of the whole maker movement, but this is kind of taking Arduino and how maybe Arduino can bridge this gap with makers and cloud companies. So this is from Peter Gallagher. Do you think there's a gap between the makers and the cloud companies? Do you think companies like Microsoft and AWS could be doing more to embrace makers? So I don't know if you have any take on this. Maybe we can kind of touch on for each of you.
In the past, I've had conversation with people that work at those companies, and some of them have admitted that there is a certain barrier to entry to some of these cloud platforms. Also, in general, I can't go into too much detail, otherwise it takes hours, but in general, it seems that a lot of these big name platforms, they basically give you a toolbox. It's almost like they give you a box full of Lego bricks, but to know exactly what needs to be plugged into what, it's something that you need to know. And so there's quite a lot of knowledge. Why, for example, Arduino, we have an IoT cloud, and our objective in Arduino is, in a way, is this idea that it just works. That's why in Arduino, we probably have more interaction designers like Sebastian than any other company of our kind, Because for us, the user experience, it is something that we are a little bit obsessed about. So this idea that you plug the cable and with the, we have these videos that with the Arduino IoT Cloud, in 3 minutes, you can build an IoT Alexa-controlled lamp that you can control via Alexa with the mobile phone and everything else. Now, this speed and sort of end-to-end type product is not something that some other companies want to do because they want to give you the tools so that you build your own thing. They don't want to be too prescriptive about the way you do things.
Yeah, I've hosted a lot of hackathons, and you bring some of these new developer boards to these hackathons. They're like, oh yeah, do this. These are the prizes sponsored by these companies. And most of the students say, well, can't I just use an Arduino? Because it's so user-friendly and they're so familiar with it. They have them on their desks, on their classrooms, so definitely feel that. Sebastian, did you want to add to that at all?
I mean, I think there is certainly there's some sort of a gap, but then again, those both worlds have very difficult problems to solve, and I do think that it makes sense to focus on one part of the story and really make that shine. In that sense, I think cloud computing still is a complex thing to do and a complex thing to learn. But then again, over the last couple of years, I think I have seen a little bit of improvement of making things easier for the end user. So let's see how it goes a few years down the road. Maybe we're going to meet somewhere in the middle.
Yeah, there's been some movements, like they mentioned AWS and Microsoft. I know Microsoft, we recently talked to them. They have these new Edge kits that you can go apply for, these developer kits that link directly to their cloud. So it appears that kind of, things are moving in that direction, taking a piece of the Arduino model, making things easier for the users. So cool.
Awesome. So we touched on a bit of the history and I learned a lot about Arduino and the start of Arduino. It's interesting that recently, a year ago, I believe, you've launched this new line called Portenta, and today we're talking about the focus of the second half will be on the Portenta. So I'm curious, perhaps we can start with showing the Portenta, actually. I mean, does anybody have one? Let's see. Let's see who's got one. There we go. I've got one as well.
I have my fake one right here.
By the way, I want to show you a little trick. So if you don't want to solder any pins to your Portenta, what you can do is you take these 2-row pins and then just stick it onto the board. It sits there perfectly well.
Very nice. So we should introduce the Portenta. I don't know who of the two wants to introduce the Portenta, and also why why the Portenta, what has changed.
I can give you the 30-second intro. Well, so in Arduino in the last few years we've been working more and more building tools for what we call the pro market. So it's there's a lot of people that maybe from what you would call a maker evolve towards more professional type products. But there's also this kind of thing that we see that certain kind of companies, a lot of either big companies or even small and medium companies, sometimes they're looking at tools that can simplify and speed up their development process. And also they realize that in certain industrial equipment, it is overly complicated and expensive, and sometimes they only need a much simpler type of technology. So we realized that we could build some microcontroller that's development platform that's simple like a regular Arduino, but has a huge amount of computing power. So the Portenta was born because we talked to ST Microelectronics, and they had this dual core Cortex M7 plus Cortex M4 microcontroller that can go up to 480 megahertz clock, which is very, very fast, and has graphic accelerator. It's got a lot of different incredible features. And we added external memory, there's a battery charger, there's all sorts of other things, and a USB-C connector where you can even get video out. So if you plug a USB-C to HDMI, you can actually get video out of this thing. So it really is a very powerful platform. And then one of the interesting things is that at the back, I don't know if the camera is going to focus enough, but at the back, there is these two high-density connectors that bring out all of the signals that are available on the processor. So this Portenta can really become the ingredient for a much more complex piece of hardware, a piece of machinery, and different from all the other Arduinos. This is built to industrial standards. So it's high temperatures, all sorts of, in a way, more extreme conditions that you find in an industrial environment. and with the high density connector, you can do this kind of sandwiches like this, where you can take this, which is Sebastian is going to talk to you about this, but this is a camera shield that you can kind of connect as a backpack at the bottom with the Portenta. So you can do these really compact things. So I think it's a completely new direction from the old Arduino.
So I love it. The Portenta looks amazing. I usually like to ask these questions when new boards come up, and I think about kind of that transition from maker to product, right? So productization. Can the Portenta be put into products? Like, is it certified globally? Is it certified in certain regions? Can it be put into products? Can it be bought in large quantities and pushed out to, industrial use cases?
Yeah, so what you see, the Portenta you normally see now is the one that's fully populated with every single option there is. So it's like top of the range. And it is certified in the major markets. The way we normally work is that we certify like US, Europe, and a number of other specific markets. And then if somebody has a specific project in a specific market and they have enough traction, we then also certify it for that market, because certification globally, it's a very complex and expensive process. Yeah. But it is imagined as essentially a building block for an actual piece of equipment. You can put this to run a piece of equipment in an industrial setting. And there will be more products that we can't really talk about now that will come out in the next months that show that kind of direction, that make it easy to integrate Portenta into industrial equipment. So, and there are versions of the Portenta that are coming out now, I think, very soon, where there are basically depopulated version where the price goes down quite a bit. And if you buy it in quantity, you can say, I want to buy 5,000 of this, but I don't need the extra memory, or I don't need the battery. You can basically get parts removed, so you can get it customized to your application, so you can shape the price according to your application.
That's a really good point. I mean, that was literally my next question, is that, a lot of times when you get to a certain amount of units, it ends up being a little more cost effective to engineer out some pieces and redesign or create a derivative design around the chip, et cetera, et cetera. So if you're providing that, that's amazing. Step forward already.
That particular, it's an important comment you made, because with a regular Arduino, which, it's either a Cortex M0 or an 8-bit microcontroller, normally it's like a dual layer PCB. So it's simpler for people to say, I'll just make my own PCB. But with this thing, not something that you can do unless you are a professional. So we have a team of, Alessandro knows Dario Pennisi, the head of R&D for Arduino. He is somebody who has over 20-something years of experience developing high-end professional electronics. So this thing is a multi-layer PCB with very complex things. It's not something that you can develop. Somebody that's like a maker or a smaller company won't be able to develop this. It costs a lot of money to do this right.
I love that. I love that. Path to product. I mean, I think that's huge for makers. So Arduino helping out people and developers get their path to product in order. I love it. That's awesome.
I'd like to think it's also a bit of a giving back to the community, right? Like, we were talking earlier about the fact that Arduino has grown with the maker movement, together, right? And it's almost like, okay, now you're actually giving a path to product to all these, amazing developers out there that are coming up with ideas, right? And with the UX kind of background of the whole, what we talked about earlier about really thinking about the developer experience, the user experience. I think, this is really a path that I'm looking forward to, and I'm looking forward to the next, boards coming out, because I think there is a real story there that could be told, and I'm waiting for all those products that are going to be built that we can then showcase, right? And I'm really excited.
So there's a question from the audience about FreeRTOS on the Portenta. So I can answer very quickly. actually the Portenta comes with the Embed OS, which in my personal, individual opinion, it's much better than FreeRTOS. So if there's a customer that says, I absolutely need FreeRTOS, we might consider it. But, we now have this nice infrastructure based on Embed OS. And Embed OS has so many amazing features that integrate very, very well with the platform that I don't think there's really any, somebody needs to have like insanely specific need for FreeRTOS for us to really consider it.
I think we'll always appreciate an Embed OS plug. So Embed OS is amazing. While we're at it, can we take this other question from iShotJR? I mean, it's a little bit off the topic, but it's I think a good one. When will the Pro IDE come out of alpha beta and be ready for production use?
So I know that it will be quote unquote released soon. So I don't think we can. I'm looking at no, we can't say that much, but I'm looking at Sebastian. I think
I'm glad you're taking on this question.
Yeah, no, I think so. It will move into, I don't know, beta or alpha, depending on, who inside the company wins. For me, it's beta. For some other people, it's still alpha. But we are probably just a few days or weeks away from like a more formal release, where it starts to become, the tool is already working reasonably, I would say it works really well. And for anybody, check out the Arduino CLI, which is the engine of this IDE. It's an amazing piece of code. It works so well. And I don't know, I think Sebastian knows more about that.
I mean, a lot of development has happened on that end in the last couple of months. And I can say that now I've transitioned to the Pro IDE because now it has become really stable and ready to use. So, don't be misled by the alpha or beta tag. So please give it another try. It's really, really usable now. And we would be happy to get also your feedback on it.
Awesome. I wanted to address, or actually kind of give a shout out to Jessica, head of Hackster, that came to say hi. And actually, I like this comment, actually. She's saying, love Portenta's potential to show the rest of the world how powerful industrial applications can come from a maker community. So, I think that's a nice message. I think that would be nice to see. So I'm really looking forward to that as well. Hi, Jessica. Thank you for joining us.
Hi, Jessica.
Cool. So I think actually one last question. Sorry, from someone that hasn't attended but has asked the question prior to the show. So about Portenta shields. So he said the question was: is there going to be other shields on top of the Vision Shield? Because right now it's the only shield available. And is there going to be availability for other sensors?
So yes, there will be other shields. There's a number of products that are in the pipeline. One of them is kind of obvious. It's going to be a breakout board that brings out all the pins from the Portenta. There are others that are actually more. There's going to be interesting stuff coming out. The Vision Shield, I'll let Sebastian talk about it. But one thing I wanted to point out that the Portenta is also compatible with the MKR product line. So you can use, there is an RS485 shield, which is an industrial shield. So it's galvanic, it's separated, it's not one of those cheap things. You can use it in a real application. There's a CAN shield. There are shields with a bunch of environmental sensors on it. So there's a number of shields for the MKR that there's also third-party shields. Like there's a company that makes a motor control shield for the MKR, works also on the Portenta. So there's that stuff will enable people to build quite sophisticated industrial type projects.
Yeah, so
thank you for the answer.
I know we're going to have to dive into the demo real quick, but David hopped in here and he wants some input on this and just kind of piggybacking on what you were just saying there. Massimo. Seems like there would be a lot of utility for Portenta in robotics and autonomous mobility as well. So any thoughts on these markets? Have you guys put any backing behind it?
So clearly it's a market that's very interesting for us. So for example, I've shipped hardware to 2 of the developers of MicroROS, which is the robust operating system version that runs on microcontrollers. So in the next, I don't know, few weeks, there will be a version of MicroROS that runs on Portenta. And obviously this opens the door to use Portenta inside any robotic sort of type device that supports ROS. So obviously that's going to be a very interesting thing. And autonomous mobility, yeah, I mean the device is quite powerful, and the fact that it has 2 cores means that you can actually partition your application, maybe have like a lower level, more real-time version of like the Cortex M4 and use the Cortex M7 for machine learning or other things. So you can really kind of build the application in a way that you take advantage from the 2 separate cores. So you can build some very interesting apps. And now, the demo on what you can do with the vision on it, it's quite interesting in that regard.
Yeah, and I think that brings us it's a good segue into the demo. You mentioned machine learning, and I think this is a good segue because a few years, maybe a year ago, I never saw any machine learning on a microcontroller, right? And it's happening now. I mean, it's not we used to talk about it as a kind of marketing thing, to get people excited, but actually now it's happening, and we're going to see it today in action, right? So Sebastian, I think you're up, and maybe give us a bit of an introduction to the capabilities and TinyML, I guess, in relation to the demo.
Sure. So I first want to quickly show you. So this is the vision shield that we've been talking about now. It comes in actually 2 versions. Either you can go for an Ethernet version, or you can go with the LoRa version, and that really depends on where you want to use it. So if you want to use it in a place where there is a good Wi-Fi and where you can plug it into the socket, then you can go maybe for Ethernet. But if you want to do some edge computing stuff, for example, you may want to go for the LoRaWAN. And I want to say like a few words about machine vision, because I think that's also a good topic to talk about. When we talk about machine learning on these boards and also about machine vision, we have to distinguish a little bit from computer vision in general, which is a bit more about understanding an image, in its details and with its context, while machine vision really is more focused on understanding just enough of an image in regards to a specific application so you can make fast decisions. So you analyze that image for process control, for maintenance checks, for robot guidance, and so on. So those are very specific applications. And in that sense, you can live with the fact that you might not have very high resolution camera. You might not have a very huge machine learning model that can run on it, but it works perfectly well for specific tailored cases. So yeah, let me show you a few things. How much time do I have now?
As much as you need.
Take your time.
As much as I need.
Yeah.
Okay.
Take your time.
Okay, so I want to first, so there's 2 things to this story. I talked about machine vision and about LoRa, so that's the connectivity part. Let me share my screen. So I want to show 2 things real quick. One of them is making a sort of vehicle/traffic analyzer, and then the other one is how to very quickly create a machine learning model and populate it onto the Portenta and run it. So that takes just 5 minutes to do, which is pretty awesome. So what you see here is the ThingStack cloud, which is basically a hosted version of the ThingStack infrastructure. So that's really a LoRaWAN backend that you can use. And I'm not going to go into detail on how to set up your account and your application, if you want to do that, there's a tutorial that we have just launched today. I can probably put that in, or somebody can put it in the chat. But instead, we're going to focus on the traffic here. So I registered my board here with the thing stack, and as soon as we get some data, we're going to see that here in the data stream. And then the other thing is the machine vision part. And for machine vision, I want to use OpenMV, which is another sort of platform that we're partnering with that allows to write MicroPython scripts that build on top of the OpenMV firmware, which has a ton of built-in algorithms for machine vision stuff that you can benefit from. So here, just to very quickly show you the basics, it's pretty much like a normal IDE. So you have your editor on the left-hand side that shows you the script that's going to run on the board. And then you have a terminal that you can use for debugging. Then on the right-hand side, you see a frame buffer preview, which you could maybe see as sort of as a camera preview, but it really just shows you any kind of visual data that you put into it. And then what's really interesting, just below that, you see a histogram. And that is very interesting for machine vision applications, because most of the times you're interested in pixel values. So for example, if I was interested in doing something here with this bottle that's on my desk, I would then need to figure out some properties. And one of those properties can be the range of grayscale values. So what I can do is I can just draw a little rectangle over that object, and then I see the kind of range of grayscale values. If you have a color camera, you would also be able to see that, the RGB values. So here we have something between, I don't know, maybe 20 and 40. So when you know that, you can extract that from the image and do something with it. But let's get to the actual example that I wanted to show you. So I took this video from my balcony a couple of days ago, which shows you the traffic in the streets. And I was trying to, write a script to figure out if there's a tram or a bus in the image. And if you have a close look at the beginning of this video, there's something good happening, which is basically nothing. So we're going to take advantage of this fact that there's no traffic in it, and we're going to do a little trick to make our lives a little bit easier. So let me go back to OpenMV and show you the scripts. Obviously, we could go for a live stream, but it's dark outside now, so we're going to go with this video file that I prepared. And what happens, it reads that video file and then does the blob detection on top of that. So let me just run that so you see what's going on. So as you can see, this already works. So I'm quickly going to walk you through how it works. As I told you, the trick that we do here is that we sort of save a still image from the beginning of the video and then subtract that from each of the frames that we read from the video. So that happens here. So in the target image that you see on the right-hand side, we just basically subtract the first still image. I can quickly show you how that looks if you comment out this part here. So now you can see that we're left with just the moving parts, which makes our life a lot easier, because now we don't have to deal so much with the background texture of the house and so on. So how can we figure out if there's a tram or a bus? So let's have a look at the script a little bit. There is basically one main function here that's interesting, which is find blobs. So that one analyzes the whole image, and it takes a couple of parameters that you can look up, for example, the minimum bounding box of the objects and so on. And then when you have that list of blobs, you can then do some further analysis on them. So what's happening here is that I basically calculate the elongation of a blob, which tells you if the object is a rather long or a narrow object. And since buses and trams tend to be pretty long, at least here in Zurich, I take advantage of that. So I say whenever there's a vehicle which has an elongation of above 0.85, that needs to be considered also if the bounding box is quite big, which is the case for those objects. And I did a little bit of a simplification here. So I'm just saying, okay, if all the buses would be the same size, I could go with a very simple, range here and say, okay, if it's between 120 and 135, I treat it as a bus. And if it's an object that's very long, and in this case, the trams, they span the whole image, as you can see here. So I can take, again, advantage of that and say, hey, if there's an object which has an elongation of above 0.9, it's going to be tram. And as you can see here in my serial monitor, that works pretty nicely. So all that's left to do is to send that information to the cloud, or in our case now, to the LoRaWAN backend. And that is actually pretty simple. So all you need to do as a preparation is you have to store your credentials in a file, which, I have it here. So it's 2 values that you need to set there. And then when you have that, you can use one of these modules that I wrote, which is called LoRa Sender. And then that basically, it checks every 18 seconds if there's a new message. And then if there is one, it sends it to the cloud. So let me remove the comments here. So what we do here is whenever there is a bus or a tram, it's going to send a message that we hopefully are going to receive on the thing stack if we check that. Bus detected. Okay, so it's now going to take a couple more seconds until this interval fires. So in the meantime, we can maybe go over to this page, refresh it. There's something going on here.
We didn't make a sacrifice to the demo gods today.
There we go. So that works. And then once you have that information, you can do with that whatever you want. So that was one thing I wanted to show you. And let me quickly take just a few minutes to show you another cool thing, which is how to train a machine learning model, which you could basically also use to make this demonstration here a little bit better. So you could run an image classification on top of all these blobs that you detect. So for that, I want to make a little demo with a fruit detection, which I hope that you guys have access to, even in Lockdown. So I was going for that. So what you need is images from your objects to train the machine learning algorithms, what it is. And the way I did it is very simple. So I recorded a couple of videos in OpenMV from a banana, an apple, and a pear. And then when you have that, you can then extract those images and use it for the training. So what you want to do is you want to give a little bit of variation to the object. So I just move it around, I could maybe get a little closer, get a bit further away. And then when you have that from all your objects, I have another script that then extracts all these images and automatically uploads it to the EdgeImpulse platform that I'm going to show in a second. So you run that, and then you tell the script you want to upload automatically. And what it does, it creates for you a folder with frames extracted from that video that you can use for the training. So let's head over to the EdgeImpulse platform. If you haven't seen it, it's very simple. I'm just going to go through the very basics of it. So what happens now in the background is that it uploads, or has already uploaded, those images to my project. And it also extracts the label for those objects based on the file name. So we now have a pear, a banana, an apple, and an unknown cluster. So you also need to tell it, what's noise, what is like none of these objects. And then when you have that, all you need to do is to design an impulse, which is basically a formula for your machine learning model. So when you click here, I already have that in my tab, you basically create a sequence of things that need to happen, which is I want to feed it some images. I want to scale them down a little bit because the higher the resolution, the slower it's going to run. So we want to go for something small. So we're going to shrink it to 48 by 48. And then we want to do a little bit of image enhancement. So it's going to normalize the images. And last but not least, we're going to apply a learning, which is transfer learning, which is made for images. And when you have that, you basically just save it and then move on to the image part. Here, if you wish, you could inspect some of those images to see what's going on. We're not going to do that now. I told it that it's grayscale, so that's great. And then you generate features from those images. And that's a very interesting thing. So when you click this button, it generates what you see on the right-hand side. And it's very interesting to see now that there's different clusters. And obviously, a banana cluster here, which is orange, is a lot easier to distinguish from a pear because it looks quite different than it is to distinguish an apple from a pear, depending on the angle of how you took the picture, obviously. But we're going to ignore that for now. And when you have that, you can just then move on with the transfer learning tab. I didn't really change anything here. I only bumped the number of training cycles a little bit. I clicked on start training, and that's really all you need to do. On the right-hand side, you see some statistics of how well the learning process performed. We're not going to go into detail here, but it looks like, at least with the training data, the model was able to, perfectly detect the different types. And then you click on deployment. You choose OpenMV, you click build, and then what it does for you, it builds a zip file that contains the model. It contains the labels, which are here now: apple, banana, pear, and unknown. And then it also creates a script for you. And to round off this demonstration, I'm going to quickly show you that script. It's very, very, very simple. So it basically loads the TensorFlow Lite file. It loads the labels file, and then there's just one function that needs to be executed, which is a TensorFlow.classify. And this function returns a prediction list. So it will tell you how certain it is that it's one of those different classes that you trained it on. And so the only tweak that I did here is that I added those two lines here, which is basically when it's very confident, meaning above 90%, that it's a certain fruit, it's gonna print it out in the serial terminal. So I saved actually my afternoon snack for you guys. So I still have my banana, my apple, and my pear. So let's have a look and see if it works. So I click play, and I point the camera on this map here, and you can see in the terminal, it's pretty certain. So that's 100% certain that it's a banana. So that's working pretty well. Let's take an apple now. That is, yeah, like 90-something%. So that, yeah, now we have 100%. So that's pretty certain as well. And then let's give it also a try with the pear. That is sometimes a banana, depends a bit on the angle. Now it's a pear. So obviously, my machine learning model is not very robust because I only took one type of apple and I trained it only on a few images. But obviously, the better you train it, the better the results are going to be. But as you can see, it really just takes 5 minutes to go from taking a few videos of your objects to training it and then feeding it back into OpenMV to do some classification. So why is that useful? You could think of an example where you deploy something like that somewhere, even in the nature. You could then, for example, use another sensor, a PIR sensor that wakes up the board when something happens, and then you can start to do some image analysis and then figure out what's going on in the image, and then decide what you want to do with it. So you can maybe capture the data, send it to the cloud. You can trigger certain actions. So that's really up to you, but it's very easy to do. The Portenta also has a battery connector, so if you wish, you can deploy that with the batteries wherever you want and leave it there as long as the battery lasts. And the Portenta, if it's in deep sleep mode, it really draws as little as a few microamps of power. So if nothing happens that it needs to act upon, it's going to last for a long, long time.
Awesome.
Yeah, that's what I wanted to show.
Thank you so much, Sebastian. Thank you so much for the demo and walking us through all the steps. We saw on this, actually, it was funny because we had a stream when Kwabena from OpenMV actually announced the collaboration with EdgeImpulse, and he did it live on the stream. But me and Robert didn't know about it. It was a free announcement that we got. It was really cool actually to see that collaboration started, and it's really good to see Arduino collaborating with more and more partners to enable TinyML on Arduino devices, right? So I'm really excited about the future of this. I think Robert, we've got one question from the audience, right?
I think we've got a couple here, and I want to be conscious of everyone's time. So if we can get those answered, and then
Cool. So let's take the first one. So the first one it should be fairly easy to answer. So usually in OpenMV, you'd put images in a classification folder. How come that was not necessary with this script, Sebastian?
I'm not sure if you're talking about any training, but I think you're talking about the image being classified. So we didn't have to do this because when we went for a live image from the camera itself, if you want to classify existing images, you would put them in a folder, but I went for the actual image from the camera.
But did you have to select? I mean, did you have to pass the various classes to EdgeImpulse? I mean, you had to specify what classes, all the bananas and all the apples and so on, right? So I imagine you've done that as well.
So for the training, you take that in the first place and then upload it to the cloud, but then you don't need those images anymore. For the classification, you can go for the live stream of the camera.
Yeah, cool. Okay, thank you.
We have one more here, real quick. So this one's from Peter Gallagher. When you were using the Things network, he's wondering, can you use a custom gateway instead of the Things network out of interest?
Absolutely, you can do that. Actually, Arduino has one gateway that we sell, which is a custom one. You also program yourself, but you can use whatever, because LoRa is really just a radio standard that works on top of whatever you want to use it with.
Awesome.
Yeah, for example, here I connect my LoRa devices to the Swisscom network.
Cool, yeah, and what you were watching here was the Arduino Portenta, and I want to post this here. We have the link to the store. You can go check out, I think this is the USA one, but if you just go search Arduino Portenta, you'll find it available, quite readily available there, but definitely go check it out.
I wanted to just take the opportunity, Massimo, to end on kind of like your future view of the embedded and IoT space, right? I think I don't often have an opportunity to ask you these questions, so I'm really kind of interested in your view. And I think in relation, I guess to kind of simplify the question, I'm asking the future of IoT in relation to really the programming environment and perhaps the languages that people are going to be using, right? Like, how do you see that evolution or that evolving?
Well, I think it's clear to me that more and more there is an interest in running high-level languages on microcontrollers, especially, for example, when you go meet people, teams who are working on backend software, they want to get into IoT, but they say, over here we're a Python shop or we're JavaScript developers, so they would want that kind of environment. And obviously, if you're experimenting or something, you obviously get like a higher productivity. But in some cases, I have a MicroPython thing over there that uses a bunch of Google APIs, and obviously there was already Python code that you could just bring in. So that's clearly one of the big directions. Also, because I think that I remember that once, this morning we were chatting, and it took a long time for certain type of embedded developers to accept the fact that you would use C. And then they took them a long time to accept C++. And now, there's always the odd person who says, "Oh, but why do you need Arduino? You could just program it in an assembler yourself," no? But I think there is now a clearer stratification between developers. So there's going to be more and more people that develop kind of at the top level of the stack, who are building kind of application. They're building the business logic of an application, and they are relying on a stack that's been designed by other types of developers. So there's going to be more people building IoT projects that don't have strictly an embedded development. In a way, even if you look at emBedOS as an operating system, if you get the chance to get some training on it, the people who explain the emBedOS to you, they will show you a lot of situations where emBedOS saves you from having to deal with the certain situations that you would have to deal completely by yourself manually if you were going bare metal. So clearly there are these stratifications that now allow people to, still on a microcontroller, to develop fairly high level, relying on other layers of code developed by people with different skill sets. So we gotta be a little bit more, how can I say, welcoming on in the embedded world of people with different backgrounds.
And maybe this is the future of the maker movement, right? Maybe it's this combination of worlds coming together and developing even more cool stuff, right? Based on all these pieces that everybody's building, right? So I think this is it's exciting.
Yeah, I think in a way that before the maker movement, people were experimenting, but they called something else. Maybe at some point they will not be called makers any longer, but that idea, that willingness of people to experiment with technology, to actually start building something with something they have no idea what it is, and learning by mistake as well, it's always going to be there.
Awesome.
Great. I think it's time we close out, Alessandro. Is that okay? Okay, perfect. So real quick, thank you, everyone. Want to remind you all, smash that like button. Make sure you subscribe to the ARM Software Developer channel on YouTube. Massimo, Sebastian, huge thank you for your time. Thank you to everyone who's watching. Is there any last things you want to add here before we close out?
Thank you very much for having me.
Same here. Thanks a lot, everybody.
Yeah, awesome demo. Alessandro?
There is the link to the example. Actually, this is the example page, Portenta H7 on the tutorials. And Sebastian, you're going to upload the tutorial that you walked us through today here, right?
Exactly. So today we uploaded the one that helps you to register your board. And in a couple of days, you're going to see what I just demoed today. So check back on the website.
And all the links that we've shared today, everything we've talked about, usually gets summarized into the description below. So make sure you check that out as well.
Nice.
Awesome. Well, guys, thank you so much. It was a pleasure to have you on the show. Massimo, Sebastian, always a pleasure to speak to you. And thank you to all our viewers for being on and being on with us for an hour and almost 10 minutes. Thank you.
See you next time.
Bye.